Hey there, I'm Brian Knowles. I'm one of the authors and maintainers of the Ruby on Rails adapter for Inertia.js. And I want to run through something pretty cool that we can do with Inertia to improve the user experience of our applications, and that is optimistic UI updates. Now, this isn't going to be an intro to Inertia style video. I'm going to assume that you're at least somewhat familiar with both Inertia.js and Ruby on Rails. If you're not, I recommend heading over to inertia-rails.dev and getting up to speed a little bit. Inertia is very small and lightweight. It's one of its strengths, so it's not too hard to ramp up on. But yeah, one of the other strengths that I want to talk through today is that Inertia gives us a sort of global store of state that is managed by our server. And so our server is managing state that we send to our client. In this case, we'll be using a React application. You can use Vue and Svelte as well. But this allows our client-side framework like React to almost be read-only. And you get that really nice one-way data flow principle that React was built on. And for me, makes React a joy to work with in this context. And so we're going to dive in here to a demo application that I've built to talk about optimistically updating our UI. So when we sign in here, we're going to see a list of NBA basketball games with their scores. We can browse around a little bit between dates, and we have this column here with hearts. We can choose to save some of these games to our account. Now, if we go over to our My Games section, you'll see the games that I selected are saved here. You can also unselect them. Okay, so what's going on under the hood here? If we look at our game row component, which is what is rendering out this row, and scroll down, we're going to see that these hearts are just Inertia.js links, and they are making either delete or post requests to our server, depending on whether we're adding or removing this game. And so what happens is that our client is not updating the state here. We are sending a request to our server. Our server is updating state in our SQL database, and then sending data back to our application. React will get that new data, re-render its tree, and then get an update for the UI. Now, in my local environment here, when we click these buttons, the response is really fast, almost instantaneous. But what happens if we're on a slow network, or maybe it's a longer time frame for this action to complete or something like that? Let's simulate some latency by adding a sleep command in a before action. And what you'll notice now here is a couple things. One, you'll see this comically large progress bar that I've wired up for visibility. And also you'll notice a delay between when I click the heart and when our UI updates. And that is what we expect to happen. Because our server is driving and managing our state, we don't update the UI until we get a response back from our server. Again, there are huge advantages to letting Rails be our global store of state. SQL databases are fantastic at making state updates. And so this is definitely something we like about Inertia. However, in this case, it would probably be nicer for our users for them to get a little bit faster feedback here. They probably expect when they click this heart that it's going to fill in immediately. So how can we do that? Well, let's talk about how this heart is rendered in the first place. You'll notice here that we're choosing to render a full or unfilled heart based on this is favorite variable. And all that is doing is looking at a list of IDs that, again, our server is sending back to our client in our page props and determining whether the current row is part of that list. Okay, so one way to do an optimistic update is to detach from Inertia. We could add a useState hook here. We could set up the state of this this heart to be driven by a local piece of state in the component. But that's a little awkward. We end up having to then resynchronize the state when responses come back from the server. We may end up passing that state around multiple components and ending up with some prop drilling. And we've kind of lost one of the benefits of Inertia, which is having this single server managed store of state. But luckily, there is something we can do within Inertia to make this optimistic updating pattern work. So what we're going to use there is a feature that was added in the 2.0 version of Inertia.js. So if you're using 1.x, you have to upgrade to get this. These are called client-side visits. Normally, when we make calls to the Inertia router, we are making server requests, just like we showed with the post and delete requests. However, Inertia.js added these client-side visits, which there's a push and a replace. And what these do are they are updating our page object without contacting the server. You can kind of see here the intent is something like a local only search function in a table or something like that. However, this here is a pretty general purpose setter for our page props. So we can use this for a lot of different things, including this optimistic UI update. So I'm going to wire this up. It's pretty easy to do. I'm just going to copy paste some code in so you don't have to watch me type, and then I'll talk through what it's doing after I get it pasted in. Okay. Cool. All right, so we've added a couple click handlers to our links here. If we look at that handler now, it's accepting an argument, Boolean variable argument, and calling one of these client-side visits. In the client-side visit, we're using the sort of functional form of this prop object to get access to the current props in our page object. We're going to spread those into the object that we return. And then the important crucial piece here is that we're going to overwrite the user game ID's prop. And you can see that is what we're pulling out of here to drive our UI. And what we want to do here is if we're adding this, we're going to append it to the list of game IDs, and otherwise we're going to filter it out. The other thing to notice here, we're preserving the state and the scroll here. If we didn't do that, we'd see behavior like this date picker might reset to a date that to the initial date, the default date that it comes with. CSS transitions might get interfered with a little bit. So we're preserving state here. That's an important little nuance. And okay, I'm going to save this file. And now let's see what happens when I click this heart. We still have our long request. We still have the latency, but notice that the heart is filling in immediately. And when we unclick, it also unclicks. So the cool thing about Inertia here is that I mentioned this earlier. When we're doing an optimistic update, we need to make sure that we synchronize our optimistic update with what comes back from the server. Now, because of the way that this is set up, when we get this page response back from the server, it's going to overwrite the user game ID's prop with whatever the current source of truth is from our server managed state, in this case, SQL database. And so we're getting almost automatic synchronization when we're doing this workflow using Inertia. You can kind of see there's not a lot of code here. One little click handler, one call to router.replace, and we've got fully functional optimistic updating in place. So that's it. It's really simple. Now, I'm going to leave this video here. However, I think there's more we can do with this application and this feature. Toggling a heart is a pretty simplistic sort of thing. We can do more involved optimistic updates. For example, I'm going to show off something here. If we click our score, we get a drawer that is opening and closing. We can drive that drawer using Inertia state, and we can optimistically update the state to give a nice experience. I want to make a video in the future showing that off. And then there's one other little thing that you might have thought of as I was clicking around here. I don't know if maybe that hair on the back of your neck stood up a little bit, but maybe you're asking yourself, if you're a jaded defensive programmer like me, what happens if I just rapidly click these buttons? What happens if I just go and toggle all of these hearts at the same time? And the issue we're talking about here is concurrent requests. And there are some nuances in Inertia.js. There's nuances in Rails. There's nuances in all these sort of paradigms of how this works. And so I think it'd be interesting to explore some of that in the future. But for now, this is the simple case of optimistic UI updating, and I think we're good to leave it for there. So kudos to the Inertia.js team for adding this functionality in the 2.0 release, and I hope it's helpful.